The last reaction type to be described is the E9 metathesis reaction. The mechanism has many of the same characteristics of other metathesis reactions. Before describing the mechanism, we'll show some abbreviated forms where the toluene sulfonamide will be abbreviated as TS. The phenyl ring will be abbreviated as PH, and the non-carbene ligands on ruthenium will be abbreviated as L sub N. For simplicity, I will redraw the product with the abbreviated structure. These abbreviations save time, but should be used only when that portion of the compound does not change in any way during the mechanism of the reaction. As before, this reaction uses the same active catalyst that was described earlier from the phenyl-substituted pre-catalyst. Ligand association with the ruthenium carbene can occur either with the alkene or with the alkyne. Both processes are in competition, but the ruthenium catalyst is generally sensitive to steric effects, so a monosubstituted alkene will usually react with a faster rate than a disubstituted alkyne. This gives a metallocyclobutane, which opens to generate ethylene and a new ruthenium carbene. This is an initiation stage which produces a carbene that will be regenerated in the catalytic cycle. Redrawing this intermediate, although the reaction of the alkyne with ruthenium carbene may be slow, when the two components are covalently bonded together, the concentration of ruthenium and alkyne must be high, and so an intramolecular ligand association occurs, which of course requires sigma bond rotation. Applying the Chauvin mechanism gives a metallocyclobutene, which can then open by retrocycloaddition to give a vinyl carbene intermediate. Of course, there are other molecules of the reactant E9 present. The alkene can coordinate as a ligand to ruthenium. Another metallocyclobutane forms, with retrocycloaddition giving the 1,3-diene product and generating another molecule of the same ruthenium carbene covalently attached to nitrogen and alkyne, completing the catalytic cycle. This concludes the video on the mechanism for E9 metathesis.